Welcome. All right, let's jump right in. Today, we're going to tackle one of the biggest, most frustrating headaches in modern applications. A user reports a slow checkout. You check all your metrics, you dig through the logs, but everything looks totally fine. So where in the world did those extra seconds go? Well, by the time we're done here, you're not just going to be asking that question, you're going to know exactly where that time went.
So let's kick things off with a scenario that is probably all too familiar. A user reports that the checkout process felt sluggish. Maybe it took 3 seconds longer than it should have. You're on the case, but you're left scratching your head thinking, where do I even start looking in this huge, complicated system?
So your first move, you go to your metrics dashboards, right? You're checking CPU, memory, average latency for all your services, and what do you see? Everything's green. The averages look perfectly normal, which gives you absolutely no clues about this one specific slow request.
Okay, plan B. You decide to dive into the logs. You start sifting through this mountain of text from the API gateway, the auth service, the payment service, and what do you find? No errors. All you have is this confusing sea of disconnected messages that doesn't tell you the story of what that one user actually experienced.
And that right there, that is the fundamental problem. Your traditional tools, your logs and your metrics, are great at telling you how each service is doing in isolation, but they have a massive blind spot. They can't show you how they all work together for that one specific request. This is where distributed tracing completely changes the game.
Okay, so let's dig into how we actually solve this. To crack the case of the slow request, we need a whole new way of thinking. We need to become detectives and follow the entire journey of that request, from the moment the user clicked checkout all the way to the final confirmation.
In the world of tracing, we call this complete journey a trace. You can think of it as the full case file for our investigation. It's the big picture, the entire end-to-end story of a single request as it travels and hops through all of your different services.
Now, every good case file is made up of individual pieces of evidence, right? Well, a trace is made up of what we call spans. A span represents just a single operation. Maybe it's a database query or an API call, and crucially, each one tells you exactly how long that single step took.
So you might be thinking, how on earth do we link all these separate pieces of evidence together? Well, that's where the secret weapon comes in, a unique identifier called a trace ID. This ID is attached to every single span related to that original request. It's the thread that connects everything. This whole process of passing the trace ID from one service to the next, usually tucked inside HTTP headers, is called context propagation. It's the magic glue that lets us reconstruct the full journey of a request, even when it crosses multiple different service boundaries.
All right, so we get the theory. Now, what tools do we actually use to put all this into practice and solve our mystery? Let's talk about our toolkit. For our evidence locker, we're going to use Grafana Tempo. It's an open-source tracing backend that's just built for this stuff. It's designed to handle a massive volume of traces in a really cost-effective way. And it does this by cleverly only indexing traces by their ID. And it integrates perfectly with the tools you probably already use, like Grafana and Prometheus.
But of course, Tempo can't store traces if our applications aren't creating them in the first place. That process of getting your code to generate this telemetry data is called instrumentation.
And for that, we use OpenTelemetry, or OTel for short. It's pretty much the open-source, vendor-neutral gold standard for instrumentation. And the beautiful thing about using OTel is that you're not locked into any single company's proprietary tools. You get complete freedom and control over your data.
And this is where things get really cool. With OpenTelemetry, for many popular languages and frameworks, you can enable automatic instrumentation. This means you can get detailed traces for things like incoming HTTP requests and outgoing database calls, often without changing a single line of your application code. It's that easy.
All right, we have the concepts, we have the tools. Now for the payoff. Let's piece together all the clues and finally solve our case of the slow checkout. This here is the ideal workflow. You can go from a high-level alert in your metrics dashboard directly to the specific, problematic traces. From there, you can find the slow operation in the trace and then jump to the exact log lines for that request. It's all about connecting the dots instantly. So let's say we find a log message that we know is part of our slow request, and right there in the log line is our golden ticket, the trace ID. This is our first real clue.
So we copy that ID, we head over to Grafana, select our Tempo data source in the Explore view, and we simply paste it in.
This is the moment we start to unravel the entire story.
And there it is, a beautiful waterfall diagram showing every single step that request took, perfectly timed and nested. And we can instantly see that one span, the call to the payment service, is taking a massive 2.5 seconds of the total 3-second request time. Case cracked.
And the time it took us from seeing the problem to pinpointing the exact service causing the bottleneck, less than a minute. That is the incredible power of having a fully correlated observable system. It's an absolute game changer.
Now that you've seen that aha moment, let's quickly cover a few best practices to make sure you're using tracing effectively in your own production systems.
You don't need to trace every single function call. The key is to focus on the boundaries. You want to instrument operations that cross network I/O, like database queries and external API calls, or significant business logic. Tracing tight loops or simple internal functions just adds a lot of noise and cost without providing real insight.
So, to recap, you now have a complete toolkit. You know that traces show the full request journey, spans pinpoint individual operations, OpenTelemetry is the standard for instrumenting your code, and Grafana with Tempo brings it all together for some seriously rapid debugging.
You no longer have to guess where the bottlenecks are. You can see them. You have the power to solve these performance mysteries in seconds. So the only question left is, what hidden problems are you going to uncover first?